Hello dear students, good morning, welcome back to the chemistry class. So in the last class we have discussed the numericals on vapor pressure. In today's session we will discuss some of the numericals on the relative lowering in vapor pressure. The numericals on RLVP, relative lowering of vapor pressure. So one of the colligative property. So on this concept, let us discuss few problems. So the first question is in this RLVP. The first question is the vapor pressure of water at 20 degrees Celsius is 17.5 mmHg. So I have already posted the question paper. So you should just see the first question. And here I am writing the data with the explanations. So see the question paper for reference. So the vapor pressure of water is given. In the first line, see the vapor pressure of water at 20 degrees Celsius is given, that is 17.5 mmHg. So here the vapor pressure of water, in short, the vapor pressure of water is given, that is equals to, the vapor pressure of water can be represented by P naught. Water is a solvent, just I am representing as A. This is given, that is 17.5 mmHg. And the lowering of vapor pressure of sugar solution is given. The lowering of vapor pressure of a sugar solution is given. Not relative lowering, just they have given a lowering of vapor pressure. That means what? P naught minus P, right? Lowering of vapor pressure. So it is a P naught, whereas something vapor pressure is decreased. Lowering of vapor pressure. That means, so here delta P value is given. This is lowering of vapor pressure, that is P naught minus P is given, which is equals to 0.061. So these two terms are given and they are asking to calculate. So here we need to calculate number one, calculate RLVP, relative lowering of vapor pressure, whereas second one is vapor pressure of solution. Vapor pressure of solution, that is just P. Vapor pressure of solution is equals to question mark, RLVP question mark. And the third one is find out the mole fraction of solute and solvent. Mole fraction of solute and solvent. See, the question is very simple. All the data is provided. So the first point, RLVP, how to calculate the relative lowering in vapor pressure? We have the formula, simple one, first one, P naught minus P divided by P naught is equals to XB, right? RLVP formula, relative lowering in vapor pressure. So here, this term is given. What is this? Lowering in vapor pressure, and P naught, that is for solvent. These two terms are given. So RLVP is nothing but, so this term is known as RLVP. This term is known as RLVP. So therefore RLVP, relative lowering in vapor pressure, is nothing but delta P by P naught, that is equals to 0.061 divided by P naught, 17.5. So this is your answer. So calculate 0.061 divided by 17.5. This is RLVP. Now see here, in this case, this RLVP is equals to XV. So therefore, whatever the answer you are getting here, that is the mole fraction of solute. So here directly I am writing the third point, that is mole fraction of solute is equals to RLVP. So therefore RLVP, therefore So mole fraction of solute is equals to, what is the answer? 0.061 divided by 17.5, that is 0.00348. Once you verify the answer. So here mole fraction of solute is 0.0348. Then what will be the mole fraction of solvent? That is 1 minus this value, 0.99 something, 0.9965. So this is the answer, something 0.996. So this is the answers we are getting. Mole fraction of solute and solvent we have calculated directly. So just only RLVP is nothing but what? Relative lowering vapor pressure, that is equals to XB. So therefore, once we get the XB value, definitely XA will be calculated very easily, because 1 minus XP, because XA plus XB is equals to 1. So the first point RLVP we have calculated, and XA and XB is also calculated. Now calculate the vapor pressure of solution. How to calculate the vapor pressure of solution? Vapor pressure of solution is nothing but what? Delta P value, already we know that. So delta P is nothing but P naught minus P, which is equals to 0.061. P naught value is known, that is 17.5, minus P is equals to 0.061. So therefore P value is equals to 17.5 minus 0.061. So this will be the answer, 17.439. Verify the answer. So this is the answer, right? Okay, let's go for the next question. Next one is second question. See the second question. The vapor pressure of pure benzene is given, that is 0.8501. The vapor pressure of pure benzene is, vapor pressure of pure benzene, that is P naught, benzene C6H6. The vapor pressure of pure benzene is given, that is 0.850 bar. Next, a non-electrolyte, non-volatile, a solid weighing 0.5 gram is added. That is 0.5 gram of a non-volatile, non-electrolyte solute is added. Solute is added. How much? 0.5 gram. Read the question. 0.5 gram of that solute is added to what? 39 gram of benzene. So here 5 gram of solute is added to 39 gram of benzene. 39 gram of benzene. So here this is the solute. So 5 gram of solute is added to 39 gram of benzene. So this is the solvent. This is the solvent. Now then the vapor pressure of solution become, so upon the addition of solute into solvent, the resultant solute plus solvent is known as solution. So this is the vapor pressure of solvent. So when solute is added, vapor pressure is reduced. So therefore the vapor pressure of solution is becomes, that is 0.845 bar. So this is the vapor pressure of solution. Calculate the molar mass of solute. MB is equals to question mark. Direct formula. MB is equals to question mark. So here first step. So I have written the given data. P naught is given, P is given, MB is equal to question mark. So RLVP formula, P naught minus P divided by P naught is equals to XB. XB. In place of XB we can write NB, that is WB by MB, MA divided by WA. Direct formula I have written. Now substitute the values and simplify. Substitution simplifications. So P naught value, it is given 0.850 minus solution value, that is 0.8 0.845 divided by P naught 0.850, that is equals to WB means given mass of solute. So how much it is? 5 gram. 5 gram or 0.5 gram? Okay, sorry, 0.5 gram. 0.5 gram of solute is added. 0.5 gram into MA, molar mass of solvent. So this is the solvent part. It is given mass. Benzene. Benzene molar mass is, so whatever the molar mass of benzene, 78. 6 into 12 plus 6. So it is 78 divided by MB that I want to calculate. WA that is given 39. Now simplify. 39 ones it is 2 into 2.5, that is 1 by MB is equals to 850 minus 845, that is 0.005 divided by 0.850 is equals to 1 by MB. So therefore MB is equals to 0.850 divided by 0.005, 850 divided by 5, so that is equals to 170. Okay, 170 grams per mole. So the MB value is equals to 170 grams per mole. Verify the calculations. So here I have written the formula, substitution, and check the simplifications, calculation part. So the answer is 170 grams per mole. 170 grams per mole. Okay, let's go for next question. Next problem. Calculate the mass of solute whose molar mass is given in bracket. Calculate the mass of solute, its molar mass is 40, which should be dissolved in 114 gram of octane to reduce its vapor pressure to 80%. To reduce its vapor pressure to 80%. Calculate the mass of solute, that is WB is equals to question mark. Calculate the mass of solute whose molar mass is given. That is 40. Calculate the mass of solute is required, or which should be dissolved in 114 gram of octane. 114 gram of octane. CH H and it have now plus 18 H 18 CnH12 plus 2 formula. Octane. So mass of solute which should be dissolved in 114 gram of octane, so as to reduce its vapor pressure to 80%. Percentage, that means nothing is given. So let us assume that initial vapor pressure of solvent is 100. Initial vapor pressure of solvent is 100. Now I want to reduce this vapor pressure to 80. So when solute is added, vapor pressure is reduced. So how much solute must be dissolved in 114 gram of octane, so as to reduce its vapor pressure to 80%. So as to reduce its vapor pressure, to 80%. Reduce its vapor pressure to 80%. Now let initial vapor pressure, that is P naught, solvent is 100. Now I am taking it is 100. Then whatever the vapor pressure of solution, the vapor pressure of solution is 80. Vapor pressure of solution is 80 because initially it is 100. Now I want to reduce its vapor pressure to 80%. So therefore the vapor pressure is 80. WB. So what are the requirements now? Apply the formula. P naught minus P by P naught is equals to WB divided by MB, MA divided by WA. Substitute and simplify. P naught is 100 minus 80 divided by 100, that is equals to WB. It is as it is question mark. MB value is 40. Molar mass of octane. Molar mass of octane is how much it is? 8 into 12 plus 18. 8 into 12 plus 18, that is equals to 114 divided by given mass is also 114. So the answer is, so it is 20 by 100. 20 divided by 100, that is equals to WB divided by 40. So therefore WB is equals to 800 by 100. So WB is equals to 8, right? So this is our expected answer. By simple methods we can get 8 grams of solute is required to reduce the vapor pressure to 80%. So if in the options 8 and 10, if both are mentioned, then this is wrong, because the answer is equals to 10. It is not equals to 8. If both are not mentioned, then nearby answer we can select any one of these. But what is the accurate method? The accurate method is, look at this, in this simple methods, okay, directly we can write like this. But in the, what is the formula of the relative lowering vapor pressure? So here P naught minus P divided by P naught is equals to XB. So XB is nothing but formula NB divided by NA plus NB. NA plus NB. If NA is neglected, if NB is neglected as compared to NA, then no problem, then this is the answer. If it is not neglected, then you will get the answer 10. So once you simplify with this formula and verify the answer, and verify this answer. Next, same, substitute and simplify. I will give the hint. P naught minus P divided by P naught. If you substitute these values, P naught minus P, P naught is 100 minus 80 divided by 100, that is equals to NB is nothing but WB divided by MB. WB by MB. MB value is given, let us WB value is X. X by 40 divided by X by 40 plus WA by MA, that is 114 divided by 114. We will get 20 by 100, that is equals to X by 40 divided by X by 40 plus 1. Now we can simplify this. So it is 20 by 100 is 0.2. 0.2 into X by 40 plus 1, that is equals to X by 40. Simplify this and you will get the answer. 0.2 X by 40 plus 0.2, that is equals to X by 40. X by 40. So 0.2 is equals to X by 40 minus 0.2 X by 40. So here 40 is common. So 0.2 into 40, how much it is? 0.2 into 40, that is equals to 1 minus 0.2, 0.8x. 0.8x. Simplified. .8x and 8 2 into 4 10 into 2 4s are and 8, that is equals to 0.8x. Therefore x is equals to 8 by 0.8, that is x is equals to 10. If both the options are mentioned 8 and 10, 10. The correct answer is, it is 10, not equals to 8. If 10 is not mentioned in this case, so we can select the answer as 8. As compared to the solvent, the mole fraction, the number of moles of solute is less when it is neglected. This will be the formula. So by neglecting this one term, we can solve by using this formula. By neglecting that NB in the denominator, will get 8. Without neglecting, we'll get the value of 10. So if both are mentioned, then 10 will be the correct options. So not 8. 8 is wrong. Let's go for next problem. Next problem. One more important concept, one more important point in this problem. If in the question a small change, grammatical mistake, what is that? If calculate the mass of solute which must be dissolved in 114 gram of octane so as to reduce its vapor pressure by 80%. So here it is given, reduce its vapor pressure to 80%, then I am taking final as 80. Suppose if it is given, reduce its vapor pressure by 80%. By 80% means, so initially 100, if its vapor pressure is reduced by 80%, then remaining is only 20. We need to take only 20, not 80. So as to reduce its vapor pressure to 80%, that means the final is 80. By 80%, then its value should be taken as 20. By taking 20, you need to calculate this. Let's go for next problem. Calculate the vapor pressure of an aqueous solution containing. Calculate the vapor pressure of an aqueous solution. Aqueous solutions which containing 5% of urea by its mass. Calculate vapor pressure of a solution, that is P, vapor pressure of solution which containing 5% by mass, W by W or M by M, urea solution. 5% of urea solution is given, aqueous solution. So which means what? It means 5 grams of urea is present in 95 gram of water, because 5% mass by mass. By mass percent it is given, so 5 gram urea and 95 gram of water. So which together mix to form the solutions, and its vapor pressure we need to calculate. And it is given vapor pressure of pure water is P0. Vapor pressure of pure water is given 23.75 mmSg. So this will be, it is given, vapor pressure of pure water is given. Now simplify. P0 is given, I want to calculate P. P0 minus P divided by P0 is equals to WB by MB, MA by WA. Substitute, simplify. This is the formula, substitution, simplification, because everything is given. P0 value is given 23.75 minus P divided by 23.75, that is equals to WB how much? Given mass of solute, that is 5. Molar mass of solute is urea. Urea formula NH2CO NH2. So its molar mass is 60. Verify. Molar mass NH2CO NH2, it is 60. MA, molar mass of solvent water, molar mass is 18 and given mass is 95. Simplify. 23.75 minus P is equals to, so 23.75 into 5 into 18 divided by 60 into 95. Simplify. So what will be the answer? Check the answer. It is 0.375. 2375 minus P. So therefore P is equals to 23.750 minus 0.375, that is 23.375 mmHg. Verify the calculations. Verify the final answers. So this is the answer. The vapor pressure of solution is 23.375. When 5 gram of urea is added to 95 gram of water, that is water in its pure form, its vapor pressure is 2375 mmHg. When 5 gram of urea is added, so 0.375 vapor pressure is reduced, therefore the solutions will having 23.375 mmHg as its vapor pressure. Is it clear? Yes, let's solve the next one more problem. See, this is next problem. This is an important problem. A solution containing 30 gram of a non-volatile solute. A solution which containing 30 gram of non-volatile solute in 30 gram of solute in 90 gram of water. 90 gram of water, which has a vapor pressure. So in the first case, it has the vapor pressure of this solution is given 2.8 kilopascal. It is given 2.8 kilopascal. Now, when further 18 gram of water is added, so that means, so your solute remains same, 30 gram of solute as it is. Further 18 gram of water is added, 18 gram. So when 18 gram is added, the total water becomes 108 gram. So in this case, the vapor pressure of solutions will be increased or decreased as compared to 2.8, increased or decreased, because I am adding the water. So water will be the volatile component. So it undergoing evaporation, vapor pressure increases. So now its vapor pressure becomes 2.9 kilopascal. 2.9 kilopascal. This is the first case. This is the second case. Now, question. So, calculate the molar mass of solute. So, in this case, calculate the molar mass of solute. Number one, calculate the molar mass, and the second one is calculate the vapor pressure of water. The vapor pressure of water, that is P naught, is equals to question mark. P naught is equals to question mark. So here you need to consider both the cases. Number one, solution. In the first case, RLVP. So put the formula: P naught minus P divided by P naught is equals to WB by MB, MA divided by WA. This is the first one. So substitute the values. P naught values is not given. P naught minus. So in the first case, P value, vapor pressure is 2.8 kilopascal. Both are given in kilopascal itself. So therefore just I am using 2.8 divided by P naught. That is equals to WB, weight of solute, that is 30 divided by MB into MA, molar mass of solvent is 18 gram divided by 90. Right? This is the first case. Equation number 1 is called as equation number first equation. Now similarly, second one, formula will be the same formula. Substitution and simplification. P naught minus vapor pressure of solution will be 2.9. It is given kilopascal divided by P naught, that is equals to 30 by MB, as it is molar mass of water is 18 but given mass of water is 108. 108. Now let us divide these two equations and simplify. So you have two equations, divide the equation 1 by 2 or 2 by 1 and then simplify. So in this case you will get P naught values, the vapor pressure of water you will get. So now and then substitute the P naught values in any one of the equations to calculate the molar mass of solute. So let us solve this equations. So equation 1 by 2 or 2 by 1, you can take any equation. So let us take equation 2 by 1. Equation 2 by 1. P naught minus 2.9 divided by P naught, LHS side. So divided by this factor, divided by P naught minus 2.8 divided by P naught, LHS side. In the LHS side, 30 into 18 divided by MB into 108 whole divided by 30 into 18 divided by MB into 19. So that is equals to. So here P naught get cancelled. So therefore remaining is P naught minus 2.9 divided by P naught minus 2.8, that is equals to. So here this term 30 into 18 will be cancelled. So MB, okay, MB is also get cancelled. 90 divided by 108. 90 divided by 108, yes, 90 divided by 108. So let's try to do 45, 2, 5, 4, next 9, 9, 5, 9, 6, 5 by 6. So it is 5 by 6, 5 by 6. So simplify. P naught minus 2.9 into 6 is equals to P naught minus 2.8 into 5. So it gives 6 P naught minus. So approximately how much it is? 6 into 2.9 or 9 into 18. So 17.4. 17.4, 3, 6, 18. 18.1 into 6.6, okay. That is equals to 5 P naught minus 3 into 5. What is the 14. 14. So simplify. 5 P naught, 6 P naught. 6 P naught minus 5 P naught. That is P naught is equals to 17.4 minus 14. So P naught is equals to 3.4 kilopascal. 3.4 kilopascal P naught. Yes, 3.4 kilopascal. So now we got the value of vapor pressure of solvent. Now I want to calculate the molar mass of solute. So how to calculate the molar mass of solute? Take any one of the expressions, any one of this equation and substitute the value of P naught. Let's take the first equation. P naught value is 3.4 kilopascal minus 2.8 kilopascal divided by 3.4 kilopascal, that is equals to 30 into 18 divided by MB into 90. 3.4 minus 2.8, that is 0.6. 0.6 divided by 3.4 is equals to 4 on the more or less 6 by MB. So therefore MB is equals to 6 into 3.4 divided by 0.6. 0.6 10. So MB is equals to 10 into 3.4, that is 34 grams per mole. So MB is equals to 34 grams per mole. Yes, MB is equals to 34 grams per mole. Is it clear? Okay. Next, remaining questions. Remaining 10 questions are there on RLVP, relative lowering in vapor pressure. Let's solve those problems on RLVP. In the next class, we'll move to the second colligative property, that is elevation in boiling point. Okay. Is the concept is clear now? Once you solve the problems, remaining problems, and do more practice. If you have any doubts, you just post in the WhatsApp group. I will give you the solutions. In the next class, we'll go for second colligative property, that is elevation in boiling point. Thank you.